Hi everyone, hello kings of mathematics. Today we are going to start with solving quadratic equations. So basically this is a very simple topic. For those who have been there saying the topic is difficult, today is the right time. So what's a quadratic equation? A quadratic equation is basically that equation that is in the form of ax squared plus bx plus c. Any equation that is in this form is a quadratic equation. So any equation that lies in the form of ax squared plus bx plus c equals to 0. This is the basic formula for a quadratic equation. This a, b and c can be any integers, negative or positive numbers. So these are the basic. This is what we are going to basically cover. We are going to cover first the factorization method, 2 the quadratic formula, 3 the completing squares, and 4 the graphical method, of which after that we shall cover the applications. So these are some of the questions we are going to pass through. I'm going to solve them, of which you will go there and research and get the revision questions. So we are going to do number 1, number 2, number 3, number 4, and we are basically going to start with the factorization method for this video. So let's start with number 1. X squared minus x minus 2 is equals to 0. So this is the solution. You get x squared minus x minus 2 is equals to 0. So if we are to compare it with the general equation of ax squared plus bx plus c, we can observe that our a is this coefficient in front of x squared, which is a 1. Our b is this coefficient before. There is an invisible one here, so it's a negative 1. There's also an invisible one here. And our coefficient of c is negative 2. So we write down that equation very well. Then we get the a, we multiply it by the b. We get the a and multiply it by the b. So that will be, we shall get 1 times negative 2. We get the product. The answer is the negative 2. After getting this negative 2 here, we get factors of negative 2, whereby if you multiply them, they'll give you an answer of negative 2, and if you add them or subtract them, they'll give you this coefficient of b, which is the negative 1. Are we there? We get after getting the product of a times b, which is a times c, which is 1 times negative 2, and we get negative 2. We get factors of negative 2, whereby if we add them or subtract them, they would give us this coefficient of b, which is the negative 1, and if we multiply them, they give us a negative 2. So let's start by getting factors of 2. We write them in coordinate form. So the first factors we have 1 and 2. I think there are no any more factors. So we keep on playing with the negatives and positives to see if we can get the answer of the b, which is the negative 1. So let's start by saying, if we make this one a negative, so that it becomes negative 1, 2. When you get negative 1 times 2, it will give us the product of negative 2. But if we get the sum of negative 1 and 2, it will give us a positive 1, which is not this b here, which is a negative. So that means, let us try out what if we make the 1 a positive and the 2 a negative. What will happen? If we get 1 times 2, it will give us a negative 2. And we get 1 plus negative 2, it will give us a negative 1. So this satisfies all the conditions. It satisfies the first condition, that if we multiply 1 times negative 2, it gives us negative 2. And if we add, it gives us our b, which is the negative 1. So that means we shall use this equation. So that means x squared minus x minus 2 is equals to 0. It's the same as x squared. Now you get this first coefficient, which is minus 2. You add the value of x, minus 1, which is the same as minus x, minus 2 is equals to 0. So from this step to this step, we have observed, it looks like, this one is a positive. Sorry for that, it's a positive. So from this next step here, we can observe it's like we've done nothing. Because if you get x, it's the same x, because it's the same x here. If we get negative 2x plus x, it is the same as negative x minus 2. So it's like we've done nothing, yet we've done something. So the next thing is to group the two, group in pairs. This is the first pair, this and this, and the next pair will be this. So we are going to factorize each pair. In the first pair, if we factorize out x, what do we remain with? We remain with x in the first one, and we factorize out x from 2, we remain with 2. In the next pair, it's already factorized, we can only factorize out a 1, we remain with x minus 2, because there is no common factor here, and we equate this to a 0. So next part, after factorizing this, we can still see among these two, we can still factorize out x minus 2. Here most people don't understand, but it's like having a times x. This is a side work, like having a times x and plus a times b. You can still factorize out why they all factorizing is just pulling out what is common, which is the a, remain with x plus b. So if we observe these two, we can see that our value of a here is x minus 2, x minus 2. Because it's applying everywhere, we factorize out x minus 2 and remain with x plus 1 is equals to 0. So after reaching this point, that's when you can conclude. You can say either the first bracket, which is x minus 2, is equals to 0. When the 2 crosses the signs, it becomes a positive 2, or x plus 1 equals to 0. When the 1 crosses the equal sign, it becomes a negative 1. So this will be our values. So to prove those values, you can go somewhere, get side work. To prove those values, make sure if you substitute each of these values into this first equation here that we have, into the first equation, we can be able to get the value of 0. So if you substitute when x is 2, this is just for proving when x is equals to 2, when you substitute in the equation, it will be 2 squared minus 2, which is the x, minus the 2 equals to 0, leaving us with 4 minus 2 minus 2, which is equals to 0. So that means our answer is correct. Clearly, if we also substitute in x equals to negative 1, you can see when we substitute negative 1 squared minus here into negative 1 minus 2 is equals to 0, we can see that we shall get an answer of, this is negative 1 squared, which is a 1, minus minus giving you a positive plus 1, minus 2, which will be equal to a 0. So we can see that basically our answers will be x equals to 2 and x equals to negative 1. I'll solve for you another equation here. Let me get a more harder one. Let me get example 2, where we have 4x squared minus 12x plus 9 is equals to 0. We are going to do the same thing. So we first write down our equation for x squared minus 12x plus 9 is equals to 0. So first of all, your answer should always be equated to 0. So long as if it's equated maybe to a 2, move the 2 this side and make sure it is always equated to a 0. So we do the same thing. We get this 4 and we multiply it by the positive 9. 4 times 9, of which we shall get 36. So we'll get factors of 36, whereby if you multiply them, you get 36. And we keep on playing with the positive and the negative until we are able to get the negative 12. So let's put each factors here. We have 1 and 36. You can observe 1 times 36 you get 1, but if you add or subtract, it cannot be able to give us our b, which is negative 12. So let's look for more factors. What if we use, which other factors can we use? We can use 4 and 9. If you multiply 4 times 9, you get 36. But if you add or subtract, we can see that we do not get the negative 12. So what if we try 6 and 6? Let's see 6 and 6. We keep on playing with the factors. If we multiply 6 times 6, we can see it will give us 36. But if we add 6 plus 6, it gives us a 12, but we want a negative 12. So what do we do for this case? This is a special case. So what if we make this a negative? Negative 6 times 6, it will still give us a negative 36. We don't want a negative. So what we do, we also make this a negative 6. So that we get negative 6 times negative 6, a negative times a negative gives you a positive 36. And when you add the 2, they give us negative 12. So the two values that we shall use are negative 6 and negative 6. So let's start. So we shall be having, we do the same thing. 12x plus 9 is equals to 0. So it is 4x squared. You get minus 6x minus 6x plus 9 is equals to 0. You can see we have done nothing. Negative 6x minus 6x gives us negative 12. We have done nothing, yet we have been able to do something. So what is common between 4x squared and negative 6x squared? We are factorizing out what is common. We can see we can factorize out 2, but x is also common. We have grouped this and we have also grouped this. Are we there? So we can see we have factorized out the first one. 2 is common. When you factorize out 2, you remain with 2x. Not so for the first one. And here factorize out the x. You factorize out now 2x, remain with minus a 3. Not so. And for this second case, we can see we have a minus out. We have a plus outside. What is common here? We can see we have 3 is common. So if we factorize out 3, what do we remain with? We remain with negative 2x plus 3 is equals to 0. But for this case, you can see, for us to be able to factorize, this factor must look the same as this factor. So how can we be able to make these factors look the same? Also, if you have a negative b, this can be side work. If you have a negative b and you want this b to be a positive, this is a negative b, it's the same as pulling out a negative outside, negative 1, and you remain with a b. If you have a negative 2b, are we there? It is the same as pulling out the negative 2 outside and leaving the b inside. So you have left the b a positive literally. So this is the same case we are going to apply for this. If we have 2x into, so this should not worry you too much. So what are we going to factorize out now? We are going to factorize out the negative. So when factorize out negative, this becomes a negative 3. Also, and that means this negative will become a positive, and this will become a, this negative will become a positive and this will become a negative. So this negative now becomes positive 2 and this becomes a negative 3. So that when we multiply, negative times this gives you this, and this negative times this gives you that, and equate it to 0. The same case, we factorize out what is common, 2x minus 3, and here we remain with also 2x minus